9 turbocharger design, from the basic single-scroll turbo in a 1980s diesel to the compound twin-turbo system in a 2024 Power Stroke. But only 3 of these turbocharger types can deliver 1,000 pound-feet of torque without catastrophic failure. The rest fail between 150,000 and 250,000 miles. Some fail even sooner. If you're towing heavy loads, modifying your diesel, or buying a used truck, you need to know which turbocharger will survive and which one will destroy your engine. The fixed geometry turbo is simple and cheap, but it creates massive turbo lag. The variable geometry turbo eliminates lag, but it clogs with soot and costs $3,500 to replace. The compound turbo system delivers both low-end torque and high-end power, but it's complex and expensive. All 9 turbocharger types explained. What's best for your diesel? Over the next 15 minutes, I'll show you every turbocharger design used in modern diesel trucks, how they work, failure points, performance characteristics, and which one you should actually use. This channel exists to prevent expensive mistakes. I use engineering documentation from Garrett, BorgWarner, and Holset. Failure data from NHTSA recall databases, owner testimony from verified high-mileage diesel forums. No guesswork, no brand bias, no marketing claims. If you're planning a turbo upgrade, buying a used diesel truck, or trying to understand why your turbo failed at 120,000 miles, this is for you. Let's begin. A turbocharger uses exhaust gas energy to compress intake air. The exhaust gas spins a turbine wheel. The turbine wheel is connected to a compressor wheel by a shaft. The compressor wheel compresses intake air and forces it into the engine. More air means more fuel can be burned. More fuel means more power. A naturally aspirated 6.6-liter diesel makes about 250 horsepower. Add a turbocharger and the same engine makes 445 horsepower. That's an 80% power increase from the same displacement. Diesel engines operate on compression ignition. They compress air until it's hot enough to ignite diesel fuel. Higher compression ratios create more cylinder pressure. More cylinder pressure creates more torque, but higher compression ratios also create more pumping losses. The engine works harder to pull air in and push exhaust out. A turbocharger solves this problem. It forces air into the engine. This increases power without increasing pumping losses. Every modern diesel truck uses a turbocharger. Without it, the engine would be underpowered and inefficient. Over the last 40 years, engineers have developed 9 distinct turbocharger designs. Each design solves a specific problem: turbo lag, soot buildup, high altitude performance, towing capacity, maximum horsepower. No single turbocharger design is perfect for every application. Here's what you need to know. Fixed geometry, single-scroll turbo. The fixed geometry single-scroll turbo is the simplest turbocharger design. 1 turbine housing, 1 compressor housing, 1 exhaust inlet, 1 intake outlet. The turbine housing has a fixed opening. The size of this opening determines boost pressure and turbo response. A small opening creates high boost pressure but slow response, turbo lag. A large opening creates fast response but low boost pressure. Weak low-end torque. This is the fundamental compromise of fixed geometry turbos. Fixed geometry turbos were used on early diesel trucks. 1980s and 1990s, Cummins 5.9 liters. 1990s Power Stroke 7.3 liters. Early 2000s Duramax 6.6 liters LB7. These turbos are simple, reliable, cheap to replace, but they have massive turbo lag. You press the throttle, the engine hesitates, then boost builds, then power arrives. This makes towing difficult. Passing on the highway is dangerous. Daily driving is frustrating. The fixed geometry turbo fails in 3 ways. Bearing failure. The turbo shaft spins at 100,000 to 150,000 revolutions per minute. The bearings are lubricated by engine oil. If oil changes are neglected, the bearings fail. The shaft seizes. The turbo destroys itself. Compressor wheel damage. If the air filter is dirty or damaged, debris enters the compressor. The compressor wheel is aluminum. Debris damages the blades. Boost pressure drops. Power is lost. Turbine wheel cracking. Extreme heat cycles cause the turbine wheel to crack. This happens at high mileage, 200,000 to 300,000 miles. The turbo must be replaced. Replacement cost, $800 to $1,500 installed. The fixed geometry single-scroll turbo is obsolete. It was replaced by variable geometry turbos in the mid-2000s. If you own a truck with this turbo, it's reliable. But don't expect modern performance. But turbo lag was unacceptable for modern diesel trucks. Fixed geometry. Twin-scroll turbo. The twin-scroll turbo uses two separate exhaust passages inside the turbine housing. Cylinders are paired. Cylinders 1, 2, 3 feed one scroll. Cylinders 4, 5, 6 feed the other scroll. This separates exhaust pulses. It reduces interference between cylinders. It improves turbo response. The twin-scroll turbo spools faster than a single-scroll turbo. Turbo lag is reduced by 20% to 30%. Twin-scroll turbos are used on some gasoline performance engines, BMW, Subaru, Porsche. But they are rare on diesel trucks. Most diesel manufacturers switch directly from single-scroll to variable geometry turbos. Faster spool, better throttle response, improved low-end torque, more complex exhaust manifold, higher manufacturing cost, still has turbo lag compared to variable geometry turbos. The twin-scroll turbo is better than a single-scroll, but it's not common on diesel trucks. But engineers wanted to eliminate turbo lag entirely. Variable geometry turbo, VGT. The variable geometry turbo eliminates the fixed opening compromise. Inside the turbine housing, there are movable vanes. These vanes can open or close to change the effective size of the turbine opening. At low RPM, the vanes close. This creates a small opening. Exhaust gas velocity increases. The turbo spools quickly. Boost arrives immediately. At high RPM, the vanes open. This creates a large opening. Exhaust gas flows freely. The turbo doesn't overboost. The engine makes maximum power. The vanes are controlled electronically. The engine computer adjusts vane position thousands of times per minute based on engine speed, load, and throttle position. This is the magic of the VGT. No turbo lag, instant boost, maximum power. Variable geometry turbos are used on nearly every modern diesel truck. 2003 plus Cummins 5.9 liters and 6.7 liters. 2004 plus Duramax 6.6 liters LLY, LBZ, LMM, LML, L5P. 2003 plus Powerstroke 6.0 liters, 6.4 liters, 6.7 liters. The VGT transformed diesel truck performance, instant throttle response, effortless towing, no lag. But the VGT has a critical weakness. The movable vanes are exposed to exhaust gas. Exhaust gas contains soot. Soot is carbon particles from incomplete combustion. Over time, soot accumulates on the vanes. The vanes stick. They can't move freely. Boost control is lost. When the vanes stick closed, the turbo overboosts. Excessive cylinder pressure, head gasket failure, engine damage. When the vanes stick open, the turbo underboosts. Loss of power, black smoke, poor fuel economy. The VGT also has actuator failures. The actuator is the mechanism that moves the vanes. It's controlled by vacuum or electronic motor. When it fails, the vanes don't move. Boost control is lost. The VGT requires regular cleaning. Every 100,000 to 150,000 miles, the turbo should be removed and the vanes cleaned. If this maintenance is neglected, the turbo fails. Replacement cost $2,500 to $4,000 installed. The VGT is the best turbocharger for stock diesel trucks. Instant response, maximum efficiency, but it requires maintenance and it's expensive to replace. But VGTs struggle with extreme power modifications. Fixed geometry, turbo with wastegate. The wastegate turbo is a fixed geometry turbo with a bypass valve. At low RPM, the wastegate is closed. All exhaust gas flows through the turbine. The turbo spools quickly. At high RPM, the wastegate opens. Some exhaust gas bypasses the turbine. This prevents overboost. The turbo doesn't overspeed. The wastegate is controlled by boost pressure. When boost reaches the target pressure, the wastegate opens. Wastegate turbos are common on aftermarket performance applications, Garrett GT series, BorgWarner S300 and S400 series, Precision Turbo PT series. These turbos are used on modified diesel trucks making 600 to 1,000 horsepower. Simple design, No moving vanes to clog with soot, can handle extreme boost pressure, reliable at high power levels, still has turbo lag, not as responsive as a VGT at low RPM, requires external wastegate for maximum performance. The wastegate turbo is the best choice for modified diesel trucks. It's simple, reliable, and it can handle 1,000 plus horsepower. But for maximum performance, you need 2 turbos. Sequential Twin Turbo. The Sequential Twin Turbo system uses 2 turbos of different sizes, a small turbo for low RPM, a large turbo for high RPM. At low RPM, only the small turbo operates. It spools quickly. Boost arrives immediately. At high RPM, the large turbo activates. The small turbo is bypassed. The large turbo delivers maximum airflow for maximum power. Sequential twin turbo systems are rare on diesel trucks. BMW used this system on some diesel engines in Europe. Mazda used it on the RX-7 sports car. But it's not common on American diesel trucks. Eliminates turbo lag, delivers maximum power at high RPM, complex, expensive, requires electronic controls to switch between turbos, more failure points. The Sequential Twin Turbo is effective, but it's too complex for most diesel truck applications. But there's a better twin turbo design. Compound Twin Turbo. The Compound Twin Turbo system uses 2 turbos in series, a small high-pressure turbo, a large low-pressure turbo. Exhaust gas flows through the high-pressure turbo first, then through the low-pressure turbo. Intake air flows through the low-pressure turbo first, then through the high-pressure turbo. The high-pressure turbo creates boost at low RPM. The low-pressure turbo adds more boost at high RPM. The result, instant low-end torque, maximum high-end power, no turbo lag, no compromise. Compound twin turbo systems are used on the most powerful diesel trucks. 2008 to 2010 Ford PowerStroke 6.4 liters. 2011 to 2019 Ford PowerStroke 6.7 liters, some models. 2020 plus Ford PowerStroke 6.7 liters, all models. The 2024 PowerStroke 6.7 liter makes 500 horsepower and 1,200 pound-feet of torque. This is only possible with a compound turbo system. Instant boost at low RPM, maximum power at high RPM, no turbo lag, best of both worlds. Complex, expensive. 2 turbos to maintain, 2 turbos to replace, higher failure risk. The compound system has all the failure points of 2 separate turbos. High-pressure turbo bearing failure, low-pressure turbo bearing failure, intercooler piping leaks, boost control issues. When one turbo fails, both must often be replaced. Replacement cost, $4,000 to $7,000 installed. The Compound Twin Turbo is the ultimate diesel turbocharger system. Maximum performance, no compromises, but it's expensive and complex. But some applications need even more airflow. Parallel Twin Turbo. The Parallel Twin Turbo system uses 2 identical turbos. Each turbo feeds half the engine. On a V8, one turbo feeds cylinders 1, 2, 3, 4. The other feeds cylinders 5, 6, 7, 8. Both turbos operate simultaneously. They share the load. This reduces stress on each turbo. Parallel twin turbo systems are common on high-performance gasoline engines, BMW M5, Mercedes-AMG, Nissan GT-R. But they are rare on diesel trucks. The compound system is more effective for diesel applications. Reduce stress on each turbo. Faster spool than a single large turbo. Symmetrical exhaust routing. Complex exhaust manifolds. 2 turbos to maintain. Higher cost. Not as effective as compound system for diesels. The parallel twin turbo works well on gasoline engines, but it's not ideal for diesel trucks. But what about electric assistance? Electric assisted turbo, e-turbo. The electric assisted turbo uses an electric motor to spin the compressor wheel. At low RPM, when exhaust gas energy is insufficient, the electric motor spins the compressor. Boost arrives instantly. 0 turbo lag. At high RPM, when exhaust gas energy is abundant, the electric motor shuts off. The turbo operates like a conventional turbo. The electric motor is powered by the vehicle's electrical system. It draws significant current, 10 to 20 amps. Electric-assisted turbos are used on some European diesel engines, Audi SQ7, Mercedes-Benz inline-6 diesels, but they are not yet used on American diesel trucks. 0 turbo lag, instant boost, improved throttle response, better fuel economy. Complex, expensive. Requires high voltage electrical system, more failure points, unproven long-term reliability. The electric assisted turbo is the future, but it's not ready for heavy-duty diesel trucks yet. But there's one more design. Twin-scroll variable geometry turbo. The twin-scroll VGT combines two technologies: twin-scroll turbine housing for improved exhaust pulse separation, variable geometry vanes for boost control. This design delivers the best of both worlds: fast spool from the twin-scroll design, precise boost control from the variable geometry vanes. Twin-scroll VGTs are used on some modern diesel engines, BMW diesel engines, some European commercial diesel engines, but they are not common on American diesel trucks. Fastest spool, best throttle response, maximum efficiency, most complex design, highest cost, most failure points, requires regular maintenance. The twin-scroll VGT is the most advanced turbocharger design, but it's too complex for most applications. All 9 turbocharger types explained. What's best for your diesel? Here's the answer. For stock daily drivers, variable geometry turbo, instant response, maximum efficiency, but requires maintenance every 100,000 to 150,000 miles. For modified trucks, 600 to 800 horsepower, fixed geometry turbo with wastegate, simple, reliable, can handle extreme boost pressure. For maximum performance, 800 to 1,000 plus horsepower. Compound twin turbo system, instant low-end torque, maximum high-end power, but expensive and complex. For towing heavy loads, variable geometry turbo or compound twin turbo. Both deliver instant boost for safe passing and hill climbing. For high-altitude operation, compound twin turbo. The low-pressure turbo compensates for thin air at altitude. If you're buying a used diesel truck, check the turbo type. Variable geometry turbos require maintenance. If the previous owner neglected it, budget $3,000 for turbo replacement. If you're modifying your diesel, replace the VGT with a fixed geometry wastegate turbo. It's simpler, more reliable, and it can handle the power. Which turbocharger does your truck have? Drop a comment below. Subscribe for weekly diesel protection videos. This is Gas Tail.